Hello, everyone. Welcome and good morning. My name is Audrey Ronas-Tobin, Director of Marketing here at CoStrategix. Thank you so much for joining our webinar, Is Serverless Right for You? Before we get started, I'd like to mention a few housekeeping items. First, your lines will be muted, but please feel free to submit any questions that you might have in the chat panel. We'll answer all the questions at the end of the webinar. And also, we are recording today's webinar, so we'll send you a link when it's posted. You don't need to worry about taking notes. We'll send everything to you at the end. And now, without further ado, I'd like to introduce our speaker, Jeff Fickley. Jeff is Vice President of Technology at CoStrategix, and he's our second most tenured employee. His passion is technology, and he finds great pleasure in constructing elegant system architectures and building tech roadmaps that further business goals. Jeff loves creating solutions that are cloud native, secure, and can scale to the immense demands and future vision of businesses. He has extensive experience in both AWS and Azure cloud providers and has implemented many production systems using serverless architectures. And in his spare time, Jeff restores 1960s and 1970s era sports cars, which is pretty cool. Okay, Jeff, take it away.
Thank you, Audrey, for that introduction. I appreciate it. And thank you, everyone, for attending today. So we'll dive right in and talk about the agenda. What we plan to cover today, we're going to first define serverless architecture. Lots of definitions out there, so we'll dive in and figure out what context we're going to talk about them today. Considerations for getting your business started, consuming some serverless services, or making the full jump to serverless architecture. We'll talk through some examples and case studies that CoStrategix has worked through on some of its customers. Talk about next steps, and then also answer any questions that come in during the presentation. So let's first define serverless architecture. So serverless really has come a long way in the last few years. But really, if we get down to the essence of what it is, it's a way to model and deploy and maintain your systems without having to manage infrastructure. You're not going to have physical servers or anything like that that you're going to have to manage behind the scenes. The hardware, so the servers in old school technology are they're virtualized, and the operating systems are managed by a third party, generally a cloud provider. In this presentation, we're going to generally focus on Azure and AWS as the cloud providers. You could easily assert this information for IBM or Google Cloud Platform, any other cloud providers out there. So the benefit of serverless architecture really is that your company can focus more on your core product. Instead of running the system and worrying about servers going down or having enough capacity, you can focus more on the features that you want to implement, your roadmap, and timelines to get everything into market to really make your business successful. Gartner has a really great document, and they quoted serverless computing is really a key technology, and it is redefining the way we build, consume, and integrate cloud native applications. So serverless is more than functions. So if we were to take a look at serverless 3 years ago, this was really functions as a service. Everybody was screaming microservices and trying to break them down into single level functions. And that was their serverless aspect of their system. It has really branched out, especially within the past 18 months. There's all kinds of cloud native services available that can be considered serverless. Here's a few that I list here. As far as databases go, lots of examples out there. I picked 4 here. Microsoft Azure offers SQL Server as serverless, and their Cosmos is their NoSQL solution. And then on AWS, Aurora is the relational database system they have that's available as serverless. And they also have their NoSQL solution, which is DynamoDB. There's several others out there. I just mentioned these. As far as queuing, Amazon Simple Queue Service, SQS, is a very good solution for if you're worried about backlogging your system and clogging the pipes. You can use a queue, and SQS is a good option that we've used on several projects successfully. ETL, so if a lot of folks out there are moving data from one point to another, they're probably familiar with extract, transform, load services. Data Factory on Azure is really a great opportunity to use serverless in those use cases. If you're going to have service layers, so you're basically grouping your APIs or your web services into a single bundle, the Azure App Service is very good at handling those types of loads. And then if you are implementing functions, these are really the backbone, the original implementation of serverless. There's the AWS Lambda, and then you also have the Microsoft Azure Cloud Functions available. Lots more other than these, but I see these used the most in recent days. So quickly, we'll talk about traditional on-prem infrastructure. We're going to kind of compare different infrastructures with serverless. So most of us are familiar with traditional. You provision the hardware, you own the hardware, and really in your organization, you generally have a centralized security and traditional operational aspect, like teams that govern those procedures and operation policies. The challenges here, most of us are probably familiar with some of these. So manual updates, you doing your own maintenance. You can't scale past the physical limits. So you're going to buy a set of hardware. You can't ever go faster than what your hardware is going to let you do. And that can really be a bottleneck in your system, especially on those high volume days. Very large upfront investment. You're going to spend thousands and thousands of dollars to buy the server hardware. You're going to put it in a rack in your data center. You're going to pay for the use of those servers 100% of the time from that point forward. And that kind of leads me to the next point. You're going to have lots of unused, capable hardware out there. In your slow times, you're only going to use a small percentage of what you actually have allocated for your system or purchased for your system. And that's kind of inefficient financially, right? If we could somehow only pay for what we use, we could definitely improve this model. And then you also have to replace your own hardware every so often to keep up with technology as it moves forward. All right, so then let's go ahead and jump to what we can call classic cloud implementations. It's funny, I remember when the cloud became available and it was all brand new. You would launch a VM. I mean, it was never heard of in the past, using cloud infrastructure. Everybody's worried about security and migrating. And now I'm calling that classic cloud implementations, but this really focuses on virtual machines or instances that you have provisioned a set amount of CPU memory network for. And there are some benefits here. You can put load balancers in front of your servers so that your system can scale up and down. And you can use your traditional development and deployment processes on this type of infrastructure. And you're only going to pay for what servers you use. Now, that granularity of the service that you pay is at the server level. And we can definitely pare that down in serverless to a smaller level, which we'll talk about in the future. But a server may cost you, from a couple $100s to a couple $1,000s a month, depending on the hardware that you have allocated for it. So this could be a considerable cost over time. The challenges here, you are still bundling a bunch of services on the server. You're not individualizing your services so that you can independently scale certain parts of your infrastructure. Like if you have a highly transactional part of your system, like let's say orders, and you have to deploy on a server, you would have to add more servers with all of your other web services available on it in order to scale your order processing. And also there is some delay now in recent years. The delay of adding new hardware for scaling up and scaling down has come down to between 5 and 15 minutes. It depends on a bunch of different factors. But you still have a small delay on when your system detects that you have an increase in volume and you need more hardware to when that hardware actually becomes available. And I mentioned the last point already. So then if we make the jump now to serverless, really there's no hardware to provision or maintain. You do have to set up lower limits and upper limits of the service that you're going to use. And keep in mind, this isn't just functions we're talking about. We're talking about Azure Data Factory services, or we're talking about data pipelines, SQS for queues, things like that. You have to set your upper and lower limits of your how much risk or how much you're willing to pay for, basically based on your volume. So it will automatically scale up very quickly to traffic spikes. There's very little warm-up period in serverless. It's not zero, but it does exist, but it's very, very small. It's not 5 to 15 minutes, we're talking seconds. It'll scale down to a very small footprint during slow times. And you set how small it can scale to satisfy what you think is your smallest footprint. How much traffic are you going to satisfy, at your slowest point? The smallest scalable unit here within serverless can be very small. A single function, for example, and maybe this is just your create order function in your app. And it can scale up. You can scale up your orders if you're receiving 1,000 orders, within a few seconds. You can scale up just the order aspect instead of having to scale your entire system up. And you only pay for what you use. So now that granularity of scalability is all the way down at the near function level, you're only going to pay for the amount of service that you use, basically at that lowest level. That can be a CPU unit or a DTU unit. It could include some RAM. It could include transaction time. There's a couple different ways in which these serverless cloud services are metered, but you really only pay for what you use. And when you're slow and you're not using the service, you don't pay anything, or you pay the minimal footprint which you have defined. Maintenance headaches are gone. You don't have to patch the operating system or underlying libraries. You don't have to worry about hardware failures. All of that is managed by the cloud provider. And one of the key benefits of serverless has really come along in the last couple of years because of the sheer breadth of how many cloud services are now available. They are natively accessible to one another. So you can leverage all of these cloud native integrations directly within your serverless infrastructure, which really will save you a bunch of time. Think of things like logging, for example, as automatic, and it's a native integration. Monitoring or even debugging. There's many more than that, but those are just a few examples. Now, with all of this comes some challenges, of course. One of the challenges that we see is kind of foremost is you have to have a mature process in place. You have to adhere to your software development lifecycle. Your developers have to follow best practices. They have to write good code. You have to have automation in place, especially during deployments, because now instead of deploying to a single server, you're deploying to maybe hundreds of functions or services. So automation is key, gets rid of human error, and it makes sure everything is moved out successfully. And the other key challenge is if you're worried about only being on AWS or only being on Azure, then you need to consider that when going to serverless, because you're actually hooking into those native cloud services and you're significantly locked in to those cloud vendors. For example, if you were using Azure Cloud Functions and you want to move your application over to AWS and use Lambda functions, there's a significant rewrite for that. So keep that in mind. There are other architectures here. There was kind of an approach between your classic cloud and your serverless, which is containerization. Maybe most of you probably have heard of Docker containers. That's one of the most common ones out there. There's hybrid cloud solutions where you have some on-prem and some cloud solutions as well. And then there are multi-cloud solutions where you leverage multiple cloud providers, maybe GCP, Azure, and AWS all together in the same system. This table here talks about some of the factors and then which architecture you should really choose from. So it talks about the classic, which are the virtual machines, the containers, and then serverless over here. So just a couple of things I want to highlight from here is that serverless is really good for event-driven architectures. And as long as you can decompose your existing application into functions. Sometimes if you have an existing application, you cannot decompose it that far down. So you may have to go to a containerized or a virtual machine service architecture. Okay, so we've talked about the definitions and kind of compared a couple different architectures. Let's talk about the ways that you can get your business started using serverless. You need to prepare the organization. There's education that needs to take place. There are a lot of moving parts in serverless that weren't there in traditional. So the way that you collect, the way that your invoices are charged, like the way that you pay for hosting, is completely different because it's metered and it's metered differently based on different services. So there's kind of the financial preparedness for your organization that you have to do. HR, you're going to have a talent, and in fact, I'm going to talk about this on the next slide. You're going to have different types of talent that you'll have to either hire for or train for. And then the way that you manage your product backlog may even change because now you're going to be able to deploy these features in a much more rapid manner. And so you may have smaller releases more often. And we'll talk about a little bit about that in the future as well. There's a security mindset shift. We have seen problems within organizations because your security folks or your operations folks are unwilling to let go of some of their responsibilities. And letting go really isn't the right term. They just have to transition to a different state. Because now, instead of security really being managed and enforced by one team, everyone that's participating in the project is now in charge of security. Every developer should know best practices. Their code is getting scanned line by line, to make sure that it fits proper best practices. Centralized security is less defined. Each one of these services that you consume on the cloud would have their own security layer. Some of them have their own firewalls or IAM services where you can define who can access what. So it's a little bit different. It's a little more spread out than what operations staff and traditional security staff are used to. Cost management, I mentioned already. The way you're billed for services is considerably different. So your finance folks will need to be kept in the loop there. Vendor locked-in, we talked about on a previous slide. And so if that's something that you're concerned about, being stuck to one cloud provider for an extended period, then somehow you'll need to mitigate that risk. Training, you will absolutely have to have some training to your existing staff. If you're not going to hire talent in with the appropriate skills, you might want to train your development staff, for example, on Agile and on getting them certified as a cloud architect, and also training them on the proper languages that are supported in the cloud serverless infrastructure. And then you also might want to do a proof of concept. Absolutely, this is like a point that you should take up and consider, because the first time you go into a serverless solution, you're going to make mistakes. Everybody does, and we see a lot of folks hitting some pitfalls, as they initially move forward with the serverless approach. So definitely pick something that you can do a proof of concept on and get some hands-on experience with. Talent I hinted about before, but this is really key. You need to train or contract or hire new folks to come in with the right type of talent. There is a cloud skills gap. If you're used to a traditional model on-prem or even containerized, the philosophy around serverless is slightly different. The way that you handle, the way you monitor, the way you scan for security is a little bit different. So that would be something that you need to address in your training or hiring. You need to break traditional developer mindsets. So they're generally tied to, okay, I'm going to focus on this one piece of code. I'm going to deploy this, and send it out. Well, now they have a little bit more responsibility. In some organizations, the developer can actually deploy their own code out into production. So they have now the responsibility of making sure it's secure and making sure it was deployed correctly and well tested. Of course, you've got automation in there, which I mentioned earlier. That is going to, hopefully stop anything prior to getting into production that shouldn't be there. And that's kind of hinted here. I mentioned DevOps and CI/CD, continuous integration, continuous deployment. All of that stuff is kind of tied together. Training them on agile methodology is a huge benefit because of the way that serverless is. There's very small chunks of work that can be deployed at a time. The agile methodology, having short bursts of development and quick deployments, really fits into the serverless architecture mindset. And then coding languages, I mentioned security already. This table here on the right kind of mentions a lot of the languages that are supported for the various products that are available, serverless products and different cloud providers. You'll see, Java is pretty global. Node.js, a lot of your JavaScripting languages, C#, those types of things. So you need to make sure you have the right talent or have the right training instilled before moving to serverless. The next thing you need to do is identify your use cases. We talked a minute ago about doing a proof of concept. Well, to do that proof of concept, you need to identify a use case. Some of the things that are great for serverless is an event-driven use case, like orders I had mentioned earlier, maybe sending emails. Anything that's kind of burstable or highly variable volume is probably a good use case that you can fit into a serverless architecture. If you can find a feature or a component that's kind of isolated from everything else that you could then mock up, within your proof of concept, that would be ideal. Some other things like data ingestion, reading data from external sources or even internal sources and routing that data to the appropriate receiver, that is a great, that's a great possibility for serverless. Anything that really is stateless might be beneficial. So the stateless would mean that nothing inside of the function requires information from some other part of the system unless it's passed specifically in. So if you have an invoice and it requires customer data, it's not dependent on the customer API or the other service. The customer information would actually be passed into that invoice function in order to take care of it because it doesn't know about any other aspects of the customer. Another thing that we've seen more and more of is image, video, and audio manipulation. Since these are generally very CPU intensive functions, people have been moving more and more of that type of use case over into serverless. Okay. So then if we move on to the next, AWS recommends a few things. In fact, they've developed this well-architected serverless framework. It's very good, actually, and they kind of focus on some key points to get you moved over to like a serverless infrastructure. First, you identify the components, define your use case or your business case, determine what scenarios would exist, and then decide the best implementation. This is kind of a 4-step guide they have. I provided the link below. It's about 73 pages, and there's lots of different scenarios in there, and it's pretty complex, but it's definitely worth a read if you're moving in this direction. CoStrategix has followed this framework several times in the past, and we can help you guide you through that as well. Azure has a nice little flow chart that they follow. If you're thinking about moving over to, moving over to the cloud on serverless, I'll just hit a couple points in here. This is going to go in a lot of different directions. But if we start at the top, are we going to migrate or build new? Let's just take an example. We're going to build our new proof of concept. Do you require full control? So are you willing to kind of let go and let the cloud provider manage a lot of your infrastructure? So we don't require full control. We'll move now, move no, and move down to HPC workload. So high performance compute, are we requiring extremely large batch type volumes of transactions coming through? No, we'll just move on down. And then microservices architecture. So are you going to bundle all of your services together? Kind of like we talked about in that, that classic model. There is kind of an approach where you can still bundle your services and run on a serverless component, and that's called the app service. We've done multiple app service implementations. That seems to work out well for like websites and asset management systems, things to that nature. But if you can break down your infrastructure into microservices, then it might be really good to consume the functions, Azure functions, in this case that they have outlined, which is really kind of that initial serverless architecture was functions as a service. And of course, you can follow this flow chart on through. I provided the link in the presentation here at the bottom. Common pitfalls. Okay, so CoStrategix has been there a few times, and we've walked our customers through going serverless. Bear in mind that going serverless may not mean your entire infrastructure is moved over to serverless. You can take pieces of it. In fact, Gartner says about 80% of customers really just move pieces of their infrastructure over at a time into serverless instead of doing a flash cut into serverless. And we hit a few of these when we were talking about how do you get started, right? Lack of process maturity, so important. You have to have those processes in place. You have to have the discipline to follow those processes, because if a process breaks, you're going to introduce some type of damage into the system, whether it be expanding your security footprint too much or exposing something to hackers. There's a bunch of different things how you could look at that. Ineffective monitoring and alerts. So you must watch how much serverless functionality you consume. So as you can imagine, serverless scales up extremely fast and to extreme sizes if you let it. And if you don't properly monitor that or set your caps, your top limits, you could have a runaway function, an infinite loop that could just scale the system incredibly large and could cost you quite a bit of money. And it also might do some damage, to your data in the system, compromise the integrity of the system, and so forth. So you must have very good monitoring and alerts set in place. Code quality, we mentioned, you need to have some code scrubbers in place to make sure you're following the right best practices. Security controls, if they're too tight, you can't do your work or the system can't do its work. If they're too loose, then you're opening it up for some malicious activity. Automation. You want to automate your deployments. Don't do manual deployments in a serverless environment. You're just opening it up to human error. These environments can be complex. And then make sure you're doing the proper testing, performance testing, security testing, regression testing, unit tests. All of those should be should be well thought out, planned, and executed. Okay, so let's talk about a few examples that CoStrategix has gone through with their customers over the past few years. So the use case here was digital asset management. So we had a client that had a bunch of teams working on a project, and they were all providing assets to the project, so files for the project. They were stored in different places across the entire organization. There was no centralized document repository. They tried to use OneDrive and they tried to use Box, and it just wasn't working across all the teams. So understanding the current status of where that project resided was near impossible, extremely difficult to say the least. The auditing of changes, so when a file changes or somebody makes a change to the project, nobody knew who did it. Nobody knows when it was done or why it was done. There was no context there. So you couldn't really audit it. And what happened was every team had their own view of how the project was going. You might have a team that said, man, this project's going great. We're on time, on schedule. We got everything delivered. And you might have another team saying, man, we're so far behind. We're still waiting on deliverables from team ABC. So really this gave a lack of visibility to the staff on all of the teams. Nobody knew where anybody was. So the way we solved the problem, we implemented a simplistic serverless architecture here where there was a React front end. I don't know if you're familiar with React. That's a JavaScript front end framework that we use quite a lot. We stored that as a static website up into Azure. This was on Azure in blob storage. So we didn't really have a web server that was running. That React site was just up in blob storage and served out through the content delivery network. And then we had an API layer that resided on the web app service in Azure. So this is a serverless component that would scale the entire API layer as the throughput requirement was needed. And then we stored all the flat files into blob storage. And you can have very granular permission and even lifecycle attributes associated with that in blob storage, which was really nice. So that gave us our security layer that we needed there. And then anything that was relational or day-to-day operations type information, customer information, project information, we stored in serverless SQL. And then on top of all of that, as I mentioned earlier, one of the main things you want to do is monitor. So Azure has this monitor service where all of these serverless services are natively tied in, which is great. Another use case was we had a customer that was trying to track vehicle telematics. This is all of the data associated with your automobile. There is just tons and tons of information about it, from your lat long coordinates to your oil temperature and pressure, to the speed, to your air tire pressure. You can see that there's all kinds of facets of the data that are collected there at any point in time. And if you think about what this is, a lot of these are things like your insurance companies. You can save if you're a safe driver, right? You plug in this piece of hardware into your car, and what that does is it connects over a 4G system and sends all of the data to an aggregator, which then you can tie in your own systems into that aggregator to understand the operations of the car and detect any anomalies, predict problems, track maintenance, and so forth. So there's lots of data coming in. The issue was they couldn't get to the data. Like, they didn't have a good system to collect these gigabytes of data and put it in a way that they could analyze it. And they had built a proof of concept, but the performance was very poor in it. It was more of a proof of concept saying, okay, we can probably get there. We can prove that we can get some of the data, but they didn't know how to move forward with collecting all of it. And then they couldn't tie that data to other internal data. Like, they had some driver information and some manufacturer information and some maintenance information all within the organization, but they weren't able to connect to the telematics data with the back of the system. And then they couldn't predict on it. Since they couldn't connect it, they couldn't do predictions, they couldn't visualize it, and then they also needed some way to perform work on that as well. So this is the system. I'll just go quickly through it. I won't go down and break it down into its smallest components. But this was on AWS. We use Lambdas up front to collect all of the data, ingest the data, acquire the data, sent that through a queue so that we didn't bottleneck downstream applications or dependencies. And then we ingested it, which is our transformative step, and that was a scalable set of Lambdas that took care of that. And then we pushed that in a couple different places. Once we pushed one path, we pushed it into the warehouse for further analysis. We pushed everything into the warehouse. And then we pushed whatever was needed operational from day to day, such as the current vehicle diagnostics. We would push into either Aurora Serverless, which is a relational database, or Amazon DynamoDB, which is a NoSQL serverless solution. Then on top of those persistent layers, the databases, we sat another set of Lambda functions behind an API gateway. So this provided another scalable opportunity for other applications to tie in and retrieve some of our data, or to write a front end, such as that work queue management system that I mentioned earlier. And even third parties could write and tie in and fetch some data, if we granted them the permission. The other side of this was machine learning and data visualization. We used Amazon SageMaker to handle our data modeling and machine learning modeling aspects, so that we could really determine some predictions on the maintenance of the vehicle, when an oil change might be needed, for example, or a tire rotation and so forth. And it also gave us an opportunity to visualize the data very nicely in Power BI. So just checking on the time here. Okay, I can go for a couple more minutes, I think. Another one was mobile marketing platform. We wanted to deliver ads to mobile devices, and the issue there was that these were third world countries, and their network latency was very poor, and a lot of times they were just offline. So how do you target those customers that are offline? They're online sometimes, and then they're offline for a substantial part of it. And if you think about those types of situations, generally subscribers have metered connections, meaning they're either prepaying or they have very small amounts of data that they're allowed to use from month to month. So we built this platform out on AWS as well. So you'll see a lot of similar things, like we use Lambdas behind an API gateway for our API layer. We use the queue service, Aurora Serverless. We also had, for scheduling the campaigns, we used CloudWatch events to kick off Lambdas on a schedule based on the configuration of when that campaign should go out. We fed the data through Amazon Kinesis, through S3. We use Parquet file format for that. And then we also pushed our content data, so the ad content, out to CloudFront, so that it was, in a forward location, so that the mobiles could retrieve the ad data when they were online. So essentially, they would pull for fresh ads, the device would, and if an ad was available, it would cache it on the device. And so the next time that an ad should be triggered, it would look locally on the device and say, okay, use the locally cached ad. If it was online, if it didn't find a locally cached ad, it would look for a fresh one. So that kind of solved our offline high latency issue. And then we added Snowflake on top of this. We are a partner with Snowflake, which is a data warehousing solution. Very good when you're prepping data for data insights and visualization. And we use Power BI for the insights and visualization aspect of this. The last case I'm going to walk through is a financial settlement data system. This system had millions of invoices received every day, and those invoices did not adhere to the same format. They would have abbreviations, or the actual format of the invoice would be done different. The field names are different. And so what they had was this bank of humans that was just going through all of these invoices every day and plugging in the data manually. They were having problems with data integrity. And then they couldn't reconcile, like, the invoice data was what was invoiced actually received. And they couldn't share that data or connect to that data, if you will, with their other internal applications, similar to how I mentioned on the Telematics solution above. And then the reporting on this was just kind of ad hoc at the time. And then they also had partners that wanted to see their data. And those partners, they couldn't get there. They couldn't silo the data, or it was too dirty, or there was all kinds of challenges in order to share that data with their partners. So the way we solved this, we built this out on Azure, and there was a bunch of data sources on the left. So we built a serverless layer that really handled the SFTP and the file data. You know, we had Excel coming in, XML data. We connected straight to databases. So we were actually building this. We use Azure Data Factory essentially in the end state of this to collect all of that. Data Factory has some very good data collection. It's really an ETL solution that's based on serverless needs. Then we had data pipelines and aggregations. So, you know, in normal data projects, you have multiple zones. One's your landing zone, where your data comes in and it's kind of raw. And then you have your gold zone, where your data is cleaned and prepped. And then you can actually create active data sets that you're going to do your work on or make your reporting on. So the flow of the data through the system was all handled. These are the orange pieces here, was all handled through serverless architecture. And then, similar to other projects, we had an API that was available as well, built on serverless architecture. And again, we use Snowflake behind the scenes because on top of the Snowflake, that's where we ran our visualizations and also did our data shares. Snowflake's really good at sharing data with maybe clients or other internal teams and so forth. So that was my last use case. So where can CoStrategix help in all of this? So it's really based on where your organization is. You know, do you have the strategic thinkers and the expertise to come up with your own strategy, or do you need someone to help guide you along the path? CoStrategix is there for that. We do a lot of consulting and strategy workshops, and not just on serverless. So for data analytics and digital transformation, to complete cloud strategies. And we can also help define your roadmap. We can do an assessment of your existing technologies that you're using, and whatever your goal is there, you know, to cut costs or to get rid of so many tools and try to move to a single tool or fewer tools. We can help in making those decisions and making a plan to implement. Then on the implementation side, we also have expertise in both architecture, design, and the actual build out of whatever your target goal is. And we can participate in digital platforms or large data platforms like we just saw. Data warehousing, if you're trying to modernize your data warehouse and move it to the cloud or use some newer technologies on it, such as Snowflake, in order for you to be able to mine the data a little bit better or understand it a little bit better. And then all the way down to application modernization. You know, maybe you've got an old school website that is taking in a bunch of transactions, but it's inefficient, it's slow. How can we help? We can help strategize with you and actually implement a new solution as well. As far as our sweet spot for technology, we have a broad spectrum. On the left side, these are all of our partnerships. We're Microsoft Gold partner for Azure. And we're also partners with Snowflake, Calibra, and BigCommerce. And then you can take a look on the right side. These are all the technologies we're very familiar with. And then what are the advantages really of going with CoStrategix? I won't cover everything on this slide, but some of the key aspects are, you know, we're there to be your partner. You know, we don't want to be just a vendor. We want to partner with your teams and make you successful. So that's our mindset, and we hope you share that mindset when working with us. We have an excellent design team that focuses on user experience. We do have some cost advantages over other firms. And then we also have talent flexibility. We have a lot of full stack developers or developers that aren't really stuck in a single technology. So we're very versatile. And then along with that, we're agile in nature. So you can go from, your initial idea to market relatively quickly. So rapid development. And so if you want to reach out and have a conversation, we'd be happy to do that. This is our contact information. This is my contact information here, and Nan is our CEO, his information as well. Our website's CoStrategix.com. All right, and now I'd like to address any questions if we have time for a few minutes.